OpenAI's latest voice update may have just made dozens of text-to-speech apps obsolete. On March 20th, 2025, they launched 3 new GPT-4 models, GPT-4 Transcribe, Mini Transcribe, and Mini TTS, that can transcribe live audio, speak with emotion, and customize tone, all through a single API. In this video, we'll break down how these models actually work, how they compare to ElevenLabs and Whisper, and what they mean for developers and voice tech overall. How the game just changed. The new voice models introduce capabilities that previous tools struggled to deliver efficiently. First, there's streaming speech to text, meaning developers can feed continuous audio and get real-time transcription back. This isn't buffered or delayed like previous solutions. It's live and more natural for conversations. Second, the models use semantic voice activity detection, helping the AI know when a speaker has finished talking. This improves accuracy in chaotic or fast-paced environments where pauses are inconsistent. OpenAI reports a 2.46% word error rate in English for GPT-4 Transcribe, an improvement over its older Whisper model and a direct challenge to ElevenLabs' new Scribe, which offers a 3.3% rate. The model also supports over 100 languages, with reliable performance across accents, background noise, and varying speeds of speech. For developers already using GPT-4 in text-based applications, adding voice functionality now takes as few as 9 lines of code thanks to OpenAI's Agents SDK. This significantly lowers the barrier for apps to adopt full speech interfaces. On the output side, GPT-4o Mini TTS offers fine-grained control over tone, pitch, emotion, and accent, all via plain text. No need for recorded samples or tagged voice libraries. It's not just about sounding human, it's about adapting to the tone the situation calls for, features that obliterate the competition. These models pack multiple key features that put pressure on existing text-to-speech and transcription tools. First, low latency performance. The transcription and speech output happen in real time, closing the gap between input and response, especially important in voice assistants and customer service bots. Second, noise resilience. These models are trained to operate in non-ideal conditions, handling background sound, fast talking, and multiple accents without degrading output quality. Third, semantic understanding. Instead of just reacting to sound waves, the model uses context to determine when to pause, when to respond, and how to frame the transcription logically. Fourth, emotional and tonal control. Instead of switching between different pre-built voices, users can prompt the AI to speak in a certain mood. For instance, a developer can ask the model to sound enthusiastic or formal, depending on the user experience they want. Lastly, plug-and-play integration. With OpenAI's streamlined SDK and API, the models can be dropped into existing workflows without extensive voice engineering or external services. Real-world use cases. Companies have already begun deploying these models and reporting immediate improvements. ElevenLabs, which automates property management conversations, switched to OpenAI's voice model and noticed an uptick in tenant engagement. Voice responses became more natural, making interactions smoother and increasing the rate of completed calls for leasing and maintenance. Another firm, Decagon, saw a 30% improvement in transcription accuracy after switching to GPT-4o Transcribe. The gains were especially noticeable in noisy environments and during unscripted user input, where older systems typically failed to keep up. Integration speed was another standout. Decagon reported deploying the model into their platform in under a day, something not commonly seen with prior voice systems. These examples point to something bigger than experimental use. With minimal setup and significant performance gains, these models are already functioning in real-world customer-facing systems. And that's forcing a new conversation about where voice AI is headed and who's still keeping up. Why text-to-speech apps are now under pressure? The launch of OpenAI's new voice models has immediately drawn comparisons with existing text-to-speech and transcription tools, many of which still rely on fragmented systems. Most traditional platforms separate transcription, voice synthesis, and emotional tone into different models or services, requiring developers to stitch them together manually. In contrast, OpenAI's approach unifies these capabilities into a single system built on the GPT-4 zero-base model. This consolidation streamlines development. Instead of juggling multiple vendors or APIs, teams can now access transcription, natural language understanding, and expressive voice output in one environment. That significantly reduces integration time and simplifies scaling voice-driven features across products. Customization also exposes gaps in legacy TTS systems. Many rely on static voice libraries with limited emotional range. Switching tones often means switching voices. With GPT-4o Mini TTS, developers can prompt the voice to reflect different moods and styles, like sounding calm, assertive, or even sarcastic, without changing the voice itself or adding complex tags. As voice becomes a core part of user interaction, this level of flexibility and integration sets a new standard. Traditional TTS platforms now face growing pressure to evolve or risk being outpaced by unified, multimodal systems that offer more control with less complexity. Comparisons with other major players. In the current landscape, three names frequently come up: ElevenLabs, Hume AI, and open-source platforms like Orpheus 3B. Each offers unique strengths, but OpenAI's recent launch draws clear lines between them. ElevenLabs has gained popularity for its human-like voice cloning and the Scribe transcription model. Scribe offers diarization, a feature OpenAI's models don't currently support. Diarization allows the system to distinguish between multiple speakers, which is critical in applications like interviews or podcasts. However, ElevenLabs lacks streaming transcription and doesn't support real-time, bidirectional voice interaction within a unified API. Hume AI's Octave TTS pushes boundaries in emotional expression, allowing users to fine-tune voice responses at the sentence or even word level. Its customization is detailed but requires more granular input, and it's not bundled with transcription or conversational features. Octave TTS is also less accessible from an integration perspective, with limited developer tools compared to OpenAI's SDK. Orpheus 3B, a new open-source model released under an Apache 2.0 license, is free to run, assuming the user has the hardware to support it. It's appealing to researchers and advanced developers who want full control without vendor lock-in. However, it lacks the multi-language optimization, customer support, and plug-and-play convenience that OpenAI provides. So while these platforms offer powerful tools in isolation, OpenAI's approach appears to be focusing on convergence, where transcription, reasoning, and voice synthesis are not separate tasks, but part of a single workflow. That difference could reshape expectations for what voice AI should look like across industries. Voice as part of the multimodal puzzle. The voice updates don't exist in isolation. They're part of OpenAI's larger push into multimodal AI, where language models no longer just process text, but also understand images, audio, and eventually video in a single conversational loop. Since GPT-4o's debut in May 2024, OpenAI has increasingly blurred the line between modalities. The model already supports visual inputs in ChatGPT, and with these new speech tools, it's becoming more capable of handling the full spectrum of human communication. In a live stream presentation, OpenAI demonstrated how their Agents SDK could be used to create custom voice bots that not only speak and listen, but also reason through multi-step tasks, like checking a delivery status, updating a calendar, or summarizing a meeting. With the addition of real-time voice streaming, these agents can now operate more naturally, reacting to spoken questions and responding verbally in under a second. That moves closer to the long-discussed idea of AI companions, or fully autonomous agents that interact fluidly with users, without the need to type. It also signals a shift from narrow AI tools, which do one task well, to broad systems that integrate input, output, and decision-making in real time. That kind of convergence aligns with trends across the AI field, from Meta's work on multimodal models to Google's Gemini updates. Voice in this context isn't just an add-on, it's a foundational layer for building more human-like AI experiences. What the numbers reveal. Beyond performance, pricing is one of the most strategic levers OpenAI has used in this rollout. The cost structure undercuts many commercial offerings without sacrificing quality and is clearly designed to scale. The pricing is as follows. GPT-4o transcribe costs $6 per 1 million audio input tokens, which comes to roughly $0.006 per minute. GPT-4o mini transcribe is priced at $3 per 1 million tokens, or around $0.003 per minute. For text-to-speech, GPT-4o mini TTS charges 60 cents per 1 million text tokens and $12 per 1 million audio output tokens, equivalent to approximately 15 cents per minute. These rates put the models in direct competition with commercial transcription services like Rev, which can cost upwards of $1.50 per minute for human transcription, and automated platforms like Otter.ai, which typically range between 10 cents to 25 cents per minute, depending on the subscription. What the numbers reveal. Beyond performance, pricing is one of the most strategic levers OpenAI has used in this rollout. The cost structure undercuts many commercial offerings without sacrificing quality and is clearly designed to scale. The pricing is as follows. GPT-4o transcribe costs $6 per 1 million audio input tokens, which comes to roughly $0.006 per minute. GPT-4o mini transcribe is priced at $3 per 1 million tokens, or around $0.00003 per minute. For text-to-speech, GPT-4o mini TTS charges $0.60 per 1 million text tokens and $12 per 1 million audio output tokens, equivalent to approximately $0.015 per minute. These rates put the models in direct competition with commercial transcription services like Rev, which can cost upwards of $1.5 per minute for human transcription, and automated platforms like Otter.ai, which typically range between $0.1 to $0.25 per minute, depending on the subscription. Open source alternatives such as Whisper remain free, but they require significant GPU resources and don't support real-time streaming or emotion-driven speech synthesis. For enterprise use, Whisper also involves additional costs related to infrastructure, setup, and maintenance. In contrast, OpenAI's hosted models are ready to deploy and optimized on their servers. This positions OpenAI not just as a research organization, but as a scalable infrastructure provider for developers building voice-driven applications. OpenAI is also encouraging hands-on exploration of the technology. Through the OpenAI.fm demo site, anyone can try out the models, and a public contest is currently running where users can share creative use cases by tagging at OpenAI on X. Winners will receive a custom radio designed by Teenage Engineering with only 3 in existence. While the contest adds a playful community element, it also reflects OpenAI's broader strategy to invite users to explore the expressive potential of these voice tools beyond just commercial use cases.